Hi, today we're going to do a time series analysis of COVID-19 data. My name is Jeff Washburn, and let's get started. First, let's understand what we're dealing with. COVID-19 is a worldwide pandemic that has greatly affected the United States and the great state of Nebraska. The purpose of this analysis is to understand the progression of COVID-19 is making across the United States with a focus on Nebraska. To do so, I'll be analyzing and forecasting the positive percentage throughout this presentation. United States data is ascertained from the Atlantic, has about 6 months of daily data. The Nebraska state data is from the Nebraska's Department of Health and Human Services, has about 4 months of data. Response variable, as I stated previously, is a positive percentage, which I'm defining as the number of daily deaths divided by the number of daily positive test cases. Looking at United States data, first off, seeing a positive percentage mean of 3.15%. Taking a look at the positive percentage realization, you can see that the sample autocorrelations that the data somewhat wanders and has a slowly dampening ACF, which is an indication of non-stationary data. For the first model, difference of data, looked at the autocorrelations of the difference data and appears to be stationary. AIC, BIC indicated fitting an ARMA 5.2 model. Estimated AREMA 5.1.2 model is shown here in red. The short-term forecast of 7 days looks quite nice, further supported by a rolling window ASC of 1.38. The 90-day rolling window ASC does increase to 13.64, but still not too bad. For the second model, wanted to look at what a trend would forecast to, so fit a signal plus noise model. So the first thing I fit the regression line against a positive percent as seen in the graph in the top left. Residuals appear to have no slope and further supported by running a Cochrane-Orchid test. However, the residuals are still correlated as shown by the graph on the top right. So fit an ARMA 4.3 with the final estimated model below in red. Great, short-term 7-day forecast has a pretty good rolling window ASC of 4.22, 90-day long-term forecast rolling window ASC of 95.84. That wraps up the United States. Moving on to the Nebraska state data. Positive percentage rate for Nebraska is 1.49. And again, looking at the overall data, get an idea on the positive percentage value on the blue line. What's interesting about the sample autocorrelation is it looks very close to white noise. Approach on this data was look at ARMA and AREMA models. For the first model, AIC, BIC did pick an AR1, so went with that. After fitting an AR1 model, the residuals showed strong evidence of white noise, further backed by 0.88 with the Young box test. And below is the estimated AR1 model in red. Short-term 7-day forecast has pretty decent rolling window ASC of 2.79. And I'd say somewhat impressive long-term 90-day forecast with a rolling window ASC of 3.35. As noted before, there seem to be some peaks on the spectral density, so use the factor table for a 1 minus b to the 7th and use an overfit table of the data to compare. Both AIC, BIC picked an AR7, and the residuals afterwards showed strong evidence of white noise. Estimated AREMA model below in red. Short-term 7-day forecast has a rolling window ASC of 2.87, not too bad, and the long-term 90-day forecast has a rolling window average of 5.49. So looking at all the models, the AREMA 5.1.2 seem to be performed the best and would recommend this model for forecasting both short and long-term for the United States. For Nebraska data, even though the AR1 has lower ASE scores for both short and long-term forecasting, I'd recommend going with the AREMA as it seems to follow the data much better. Looking forward, would want to continue to collect data on a daily basis and continually update, revise the models, looking at an MLR with correlated errors, a vector AR, and neural networks. Appreciate your time. If you have any questions, please reach out to me. Thank you for your time.